Okay, so let's start with basics with tree again. And this our first question is a symmetric tree. So let's see what we have to do in this. Let's understand your question first. Given a rule in a binary tree, check whether it is a mirror or itself symmetric around the center. Okay, so for left, check for right, and right for check for left. Okay. Um, s- so in this question, we have a tree, right? We can see that when you go in left and right from same base, you check for left with right. It's just like you are going in a function. If you are going left, then for second you should go for right. And if you're going for left in one side, sorry, in one side if you are going for right, then in other side go for left. Okay, so I think we have to make a function in which there should be two. We will send a left and right. We can name that root 1 and root 2. And then right in root 1 we have put this 2 and on root 2 we have put this 2. Okay, so first we if uh, root 1 and root 2, if both are present then just check if they are same or not. So if root 1 root if root 1 double equals to root 2, then here there are two paths for both roots. Go for left and go for right. So if in root 1, if uh, if we are going towards left, so in root 2 we have to go towards right. And same we will do for other sides. If we are going towards right in oh sorry, root 1, then going left in root 2. Okay, and okay, and if both are not present, If not, root one. Oh, God. If not root one and not root two. Agar both are not there, then just return true. Else, if there is any other condition that follows, then just return false. And in if both are root, then these will be returned. And with the and in between. Okay. Let's go through and check out if this code works or not. Okay. Let's go with it. So first we will make a function with root one and root two. If not, return true. No. Let's go with this. If root one and two, then we have to check the values, I think. Yes, we have to check values. If if root one dot var is still equals to two dot var, and just return our function root one dot left. If we are going in left direction, then we go to right. And if both are not same, just return false. And if root not right and right, then else return false. To return function with Going from left. Okay, so let's run this code and check if this works or not. And it doesn't work. The number of reading materials is in the range of 1,000. Okay, the one. So, output is not a possibility. We have left and right. Yes, in which case, fails. Just filling in two, two, and returning false. Oh, okay, okay. Root two dot val. So let's see. Okay, let's see how this. Yeah, and let's submit this code. Okay, this is okay. Okay, so now we have the same question. Let's see. So we have traverse and find out if this works or not. Okay, so here was a tree, that tree. Okay, so now we have to go without using regression. We have to traverse in this. Uh, okay, so in recursive method, we have taken two things in left and right. So we will do the same thing in this also, I think. Let's take a stack, and in stack we will say over these two, left and right. And as as we know, this is the last element, and we will pop these guys out and check if these are same or not. If these values are same, then we will go for left and right. So 3 comma 3 and 4 comma 4. These two guys will come. Okay, this can work. Okay. So so we have to make a stack at first, and in a stack we will say our root dot left, comma, root dot right. These two things will be on our, will be in our stack, and then we will run this while loop while stack, and we will pop these guys out and take the root root 1 and root 2. Okay, this will pop this one out, and we will check if root 1. Okay, the first thing we have to check is root 1, and if root 1 and root 2, if both are there, and uh, no, we will go for in life condition, and then we will check again if root 1 dot val double equals to root 2 dot val. If both condition follows, then we will just put the next left and right in the stack. Stack dot append. As we know, if we are taking the root 1 left, then we will take the right of root 2. And if this condition doesn't follow, then just return the false. And here again, else if not root 1 and not root 2, then just return Um, if both are not there, then just I think do nothing. Okay. Uh, just do nothing. Because we don't have to return true because we are not doing recursion here. So we will just continue. And if uh, both condition doesn't follow, then return false. Okay. So we have popped out the stack and sorry, we have to append one more thing in our stack. So that is stack dot append root one dot write and root two dot left. Okay, I think this code will work for us. And if or if return no stack. Well, let's code this out. So we want to make a stack, and in a stack we have to put our root dot left, comma, root dot right, and I'm not taking if not root because it is already given that there is a one at least one node is there. Okay, so while stack, just take the root one, root two, is custom stack dot pop. So pop this guy out. Okay, if not root 1 and not root 2, just return true. If root 1 and root 2, if both are present, then check for if root 1 dot val double equals to root 2 dot val. If both values are equal, then just append in a stack both values. Dot left, comma root 2 dot right, and same goes for stack dot append root 1 dot right, comma root 2 dot left. Okay, and if this condition doesn't follow, then just return the false. And if this condition doesn't follow, then also return false. And because we have taken this condition first, so we can merge these two conditions also. Okay, let's run this code and check it out. This works or not. Okay, it's accepted, I think. And it doesn't work. In which case, the output is true, but it's we are expecting false. Let's check if we have done something wrong here. We will make a stack in which root dot left and root dot right over there. And while stack, just root one and root two, yeah, let those guys out. If both are not there, then just return true. And if root one and root two are present and both are equal, then just take the root one left, root two right, root one right, root two left. Also turn false, return not stack. Okay. The only change we have done is we have removed. Yes. I don't think this will change anything, but still, let's add it also. Maybe. Let's bring the both rates. Only two? Dot left and we got right. 2 comma 2. And after this, we should return the false, not. And it means we are going in else condition. And else condition is returning false. Let's also check if we are going in else condition or not. So after 2 comma 2, we are going nowhere. Why? and I'm spending the route to one equal right in stack. Okay, let's print the stack here to check if okay. Stack this game and the first this giving this one stack and then two. It's only running two times. Open to my code. When we are on 2 comma 2, now we are checking. Oh, okay. If not written, continue. This is the real problem here. If both are not there, just continue. Even in our like here, I have given the continue, but still I just forgot about it. That in here, and it works, but it is not the best solution. Let's check what is the best solution. Uh, okay, it is a recursion based. Oh, okay. Okay, let's go for okay, let's go for another question. Oh, the next question is left view of binary tree. Okay, so left view. So whichever comes left at that height, if the tree is empty, return the empty list. Tree applies to left views of the binary tree. Left view of the binary tree is set to most visible when the tree is viewed from the left side. Okay, so let's understand this question more clearly. Okay, so in left view, given is 1, 2, 3, 4, 5, 6, and let's also put 7, 8, and 9. So if it is a left view, so it will give the output 1, 2, 4, 7, 9. So like we can see that in each height, in each height, whichever we get first will be our, like in when we traverse in this direction, like left, the first guy we get in this height, like this height is 0, 1, 2, 3, and then 4. So whichever the first guy we will get on a new height, that we will get as our answer. So like we have to do simple traversal with its height, and if we get the height first time with its value, then we have to save that in our list. So how we are going to put this? Uh, First get the base, then go for left, and then go for right. So base, left, and right. While going, we also have to take the uh, our height. So global variable answer is needed with maybe set. This set will contain the height. Okay, and then we have to run uh, a function. In that function, we have to send our node with the height. Um, if not root, just return, and if there is a root, then if height not in set, if a height is not available in our set, then just put this height in our set, and while putting, we also have to put this guy in our answer. And value of like node, whatever is our node is, and if not in set, then do this. If it is in set, do nothing, and go for next height. Function node dot left with a height plus 1. and function node dot write right plus 1. So I think this will cover our answer, and we have before returning we also have to call our function. Call our function with the node that is root with the height 0 and return our answer. So I think this should work. Okay, let's go code it and check if this works or not. So here we go. We are making a answer variable that will save our answer that we are going to return. And we are making a set which will save our height. And here we will make a function in which we are going to put a node with the height, and if not no, then just return. If there is no, check if if height is in set. If it is height not in, if height not in set, just add this guy in our set dot add, and then also add this guy in our answer. uh, Answer node dot data, and because these are not in this function, so we have to use non local answer and set. And after appending, we also have to go for root left and right. So node dot left and height plus 1, and same for node dot right, height plus 1, and after going in can just return. And we have to call our function, and in case of node we have to put our root. I think now it's complete. Okay, let's run this code and check if this works or not. And it works. Check for each case. And it works. Okay. So I think I have also done this work previously sometime. Let's run in 2023, 2 year earlier. Okay, for left use company. Now we also have to do this code using traversal. Okay, for to traverse, Okay, so now we have to traverse in this without using recursion. So if um okay because we are using, like, we can use Q also. I think with this question can be solved in both way. Let's go with stack first and check if this works on it. Okay, in stack first we will put our one. No worries, with 1 comma 0, and we will also make our set. And as you know, the height, uh, it's node and height. And as we pop this guy out, we will get this 0 height that is not in our set. So we will add this in our set, and also in our answer we put our 1. Okay, no worries. And now we know that in stack we also pop the last guy out. So if we push left guy first and right guy in second, so when we will pop, right will be right will be pop out first. But that we don't want, okay? Because if right first popped out, then the height we get first with on the right side. We will get in our answer right element, but we want left element. So what we are going to do, we are going to append right guy first, then left guy. Okay, for now, if we are appending right guy first, then 3 comma with a height 0 plus 1, that is 1, and go for left 2 comma 1. It's just height that is increased. Okay, and now we will pop over 2 comma 1, and then again we go we find out the height one first time. We'll add this in set and the value also in our answer. And as we pop these guys out, we have to get its left and right. And we are appending first right guy. So right guy will be appended first. That is 6 with the present height plus 1, that is 2. And after that 4 comma 2. And now we will pop the last guy out again, 4 comma 2, and we are getting 2 height first time, so we are going to add this guy in our set, as well as we are going to put this in our answer. Okay, so now okay, we have popped these guys out, and because there is nothing on left and right, so we will pop now this guy last second, that is 6 comma 2. So now in 6 comma 2 we will first append right guy, and 2 is already in the set, so we will do nothing and go for right. So for right it's 8 comma 3 height plus 1, and same for 7 comma 3. Okay, now we know Now we get 7 comma 3 in last, and we will pop this guy out, and we get 3 first time. So as we know, whichever we get first time, take its value in our answer. And again, there is nothing in 7 left or right. We are going for again pop. We pop 8 comma 3, and there is only one in 8 comma, that is 9. We'll give 9 comma 4 and go for 9 for pop, and 4 comes first time, and that thing is set. Also 9 in our answer. And this way we will get our answer, and we know 1 2 4 7 9, we got it's our answer. And there is one thing that I notice, uh, that I think we don't need all this set. We can save this space because we are going in linear way, 0 1 2 3. So maybe we can save this place. Okay, and in the place of using set, we will use two variable. No, one variable, I think, present. Okay, present count or something. That will just save the present count. Initially it will be -1, and as we get 0 first time, and because 0 is greater than -1, we will replace -1 with 0. And while replacing, when replace the present, we will put that guy in our answer also. Okay, so if we have to code this, we need as our stack, and in stack we are putting our root with a height 0, and we are not using set, we are using present. Initially it's -1, and answer that we are going to return last. So now we are while stack. Okay, and in stack we have to pop out our node with its height, and as we are popping these guys out, uh, now we have to check its height. If if height is less than our present, oh sorry, greater than present. If height is greater than present, then just update our present, and after that we also have to update our answer. Answer dot append with the node dot data, and after doing this, now if node dot left is there, then just append in our stack. And append in our stack with the value of node dot left. and height plus 1. And same goes for right also. I think this will complete our code, and after this, just return the answer. Okay, let's code it and check if this works or not. Okay, so we are making our answer and a stack and present goes to -1, and then in stack there is also, let me check if root is okay. Number of nodes can be 0 if not root, return this. Okay, and if there is root, and then root comma 0. Not right, suppose stack dot pop, and after popping, if height is greater than present, then just add this kind of our answer. Like first to update the present. Okay, present, and after this present is first to height and enter answer dot append node dot data. Now if node dot left is there, then just append this guy in a stack. Node dot left with height plus 1. Right, height plus 1, and after this, just return our answer. Okay, there is some error. That's okay. In operating, mm, HEIGHT. Okay. And my output is 135. Underscore 124. Okay. Here we have the mistake. We have to put our right thing first, as we have checked in here. Like okay, we are. Oh my God. Here also I am putting left first. Now it works. And yeah, it works. Nice. So we have done the left view, and in the same way, I think the right side view also work. But the only difference is that before going to left, we have to go for right. So the same thing will work. Copy and paste this guy here. Normal set in the place of the root. In place of data, they here you can use value, and because it is right side traversal, right side view, so we have to just left convert these things, these two things. I think that is complete. Yeah, it works. And submit. And it will work. And for traversal, as we have done previously, in the previous left side traversal, we are going to do same thing. Just we have to change a little bit. Like here, put not in place of data, please use value. And in place of checking left, we will first check for left and then right. And this also works. See, so left and right both works in the same way, just we have to interchange the left and right. Okay, now top view of binary tree. So now we know that in top view, only the outer only the outer nodes will be there. So let's see how this works. There's one, two, three, four, five, six, seven. Let's make one more eight. So for top view, we have to get these guys. Who travels from one. Uh, so there is also a possibility like fives or like six, seven, eight, nine, and then here 10 and 11. This guy comes out. So now how we are going to do this. So here width, I think. Like first we are taking the height, now taking width. But height was easier to take, but how we are going to take width? And in width also we have to get the first and last guy. Let's make this tree again. So 1, 2, 3, 4, 5, 6, I think 7. And here comes 8 and 9 and then 10, then 11. So if it is top view, then in top view I will count 4, 3, 2, 1, 5, 6, 7, and 12 also. Sorry, 11. I think 10 will also count because these two guys' height are equal, and okay, the 8 will come here, 7 come here, plus 11 will come. Okay, so how to do this? So, like, we have to find the most right and most left nodes in our tree. To find the most left and right, we go for first we find the left, all the left guys with different height. If according to that, 9, 7, 7 will work, but not 8 and 10. We find left view and right view because if we find the right view, it will give 8 and 10 also, and that we don't want to be in it. 7 plus 1, here plus 1, then again 54 plus 1, we go over right, then -1. So if chi goes this section -1, then +1, +1, +1. So if we count it here, so 0, 1, 2, and then 3. Okay, it's 2, and -1 it becomes 1, and this will become 2, and this will become 3, and this will become 4. This can work, I think. Okay, let me clean it and fill properly. Okay, so here our height is 0, and we will make a function that will find the most right element. Okay, and we are also giving it height also. Okay, but there is a trick. Okay, see, we go towards right, then add 1, and going right again 2, going right again +1. And if we go left, then just subtract -1, then 2 become 1, and now we are going again right, it become 2, and again then 3, then again it becomes 4. So now we know we have to just check the element that have a different values, and we have to do same for our left view also. So now we have to make two functions, one for right and one for left. And after finding the answer, we have to merge the left answer with our right. Let's go for one direction first, and we know for another direction we will work the same. Okay, this time let's go for right one. Okay, so function right. Okay, for in right we are giving it node, comma, like height. Okay, after this, in this function, we will have first we are giving preference to our right direction. If not node, then just return. And if there is node, check if this height present in our set. Yeah, we are going to make a set also with answer. Okay, if height not in set, if not in set, then just add this guy in our set. Oh, in place of set, we should use present, as we know that there is no need of present is equals to -1. Okay, now here, if present is smaller than our height, then just update the present first, and after updating also add this node in our answer. And after this just go for left and right. And because like in here it doesn't matter if you go first left or right, because if we are going in left direction, so we are decreasing the height. No, dot left comma height minus 1. Okay, and for left and right, and after this now we have to do nothing. This code will give all the outputs for right height, and we have to do this whole same thing for left also, and that will give our answer. Let's try, let's code it and check if this works or not. Okay, first we have to make a function for left view. So def uh, top left, sorry, top left view. Okay, for top left view, and we are giving it node with the height, and we are using non-local present uh, present, or I say max height, and the answer here put answers questions in empty, and on max height is equals to -1, and we are using non-local. And now if first of all, if not no, then just return do nothing. And if there is no, check if max height is less than the present height. If this becomes true, then update our max height. And after this updating the height, we also have to update in our answer dot append the known data. And after updating this, we have to go for left and right both side. But while we go for left, we will increase the height +1, because right now we are checking for left direction, not for right. And when we go for right, we have to decrease height. I think I should not take the height element. I should take another. Well, it's okay if I took it. And because it is left view, we will see in left view it will be 1 comma 2, but output is 2 count, then we have to reverse our answer. And after reversing, we have to change our max height equals to -1 again, because now we are going to run for. Well, I think we can do this thing in same. But max height, we have to put the max height left. Max height right. Okay. And here height left, comma, height right. Okay. And if max height, in place of answer, we have to make a answer left, comma, answer right. Because I don't want to insert in the first position, that will increase the complexity. Because when we use insert, it will take O n time. Okay, so here answer underscore left. I have to reverse it. Answer underscore left plus answer underscore right. Okay, and because left and right both contains the root node, so I have to pop that guy out in from one of these. So I have popped that guy out from the left side. Okay, so in traversing, so for right underscore left, it will be -1, and here it's +1. Right underscore right +1. No, no, no. If we are going in left, then height should be plus, and for right, it height should be minus. No, it's percent. Okay, nice. And for here, because we are now using 4 non-locals, so answer underscore left, comma answer underscore right, max underscore. Okay, so here we are. We got them all, and we have height underscore left. If max height is less than this guy, then we have to update this left. And we are going to append, but not in answer that. Same goes for max, right? Also, okay, for both this I have added it. I think this is our complete code, but let's check it again from starting. Uh, let's change its name from left, right. Here comes that is our root and 0.0. Let's see if this works or not. Top left view is not defined. Oh, okay. Uh, here we have it. On the line 28, root 0, comma 0. Well, I have to pass these guys. Okay, okay. If not root, I'll get it. Okay. Class back, line 32, line 32. Come on, it just show me the whole error. 32. Yeah, 29. Not dot left, not dot right. Height underscore left plus 1, height underscore right minus 1. If not right, return. No worries. Answer of answer right make me marry. Okay. Max underscore left. Plus max height left. max height, max height right. Those are management node height underscore left, height underscore right. If not node, just return to nothing, and then add these guys. If max, okay, just apply the dot one. Same for right. Well, code looks like if code is right, let's check ask you maybe this guy's if something there are message get the runtime shown the code reflects to the function of that especially it seems there is a typo in column line 32. Line 32 a typo. Okay, height left where height SEIG okay HT it was a typo. Yeah, it works and it doesn't works. We put outputs 1, 2, 4, 6, 12, and 14. The output should be 1, 2, 4, 6, 8, 14. 12 should not be here. Let's ask our chat GPT, I think. Listen, what is related to how you are traversing the tree to find the top node. Next one, you are considering the horizontal distance of each node correctly and updating the visible node accordingly. Pay close attention to how you are adjusting the height of the left and right subtree. Okay. If I am going left, just the height of left will be increase and the height of right will be decrease. And same goes for right. If I am going right, left height should be decreasing. I think let's ask ChatGPT what I am doing wrong because I am not able to understand what is wrong here. Okay, let's do the solution. Copy it. Go for ChatGPT. I just paste it. Okay, terminate first scene at horizontal distance. Just comparing height left and height can break for some trees. Use BFS was with horizontal distance mapping. Use apply for level order traversal. Oh my god. Level order traversal. Drag node horizontal distance of each node. Store the first node counted at each horizontal distance. That is the top. We finally written the node in increasing order of horizontal distance. Oh, it is more hectic. Okay, it's 1 hour 20. I think it will take more time because for left, oh sorry, right now we are doing this code for uh with recursion, and we also have to do this code with traversal without using recursion. Let's call this day and understand, and let's come tomorrow. Okay, thank you guys for being together with me. Good night.